Good afternoon, ladies and gentlemen. It is a great pleasure to be here and present at this conference. My topic, optimization of energy efficiency of HVAC systems using heat pumps, is presented from an angle from an engineering practitioner, energy management consultant who deals with design and implementation of energy efficiency projects on a regular basis. I will present 3 different case studies involving different applications of heat pumps and different type of heat pumps. Before that, I will give you an overview of heat pumps and their applications in the context of an energy efficient heat pump system. So three different case studies. First one to do with ground-sourced heat pumps. Second one, air-to-air heat pump working in a close control environment, 24/7 regulated temperature and relative humidity. And third one is about industrial environment, sewage treatment plant where a heat pump generate hot water, reducing the cost of expensive LPG fuel and LPG fuel. So let's move on. Motivation to improve energy efficiency, including use of heat pumps, certainly increasingly high energy costs all around the world. Adverse impact of HVAC system on the environment and awareness of limited fossil fuel energy resources. Typical applications of heat pumps for cooling and heating for smaller facilities. We have to emphasize that in the context of cooling and predominantly cooling climates, for larger facilities, chillers are used, providing better energy efficiency. Domestic hot water heating for aquatic centers, even sometimes for cooling in tropical areas, and industrial thermal applications. This is just one example of one of the current projects that we do. So this is a high school boarding house with 4 wings, where we use air-to-air multi-head split heat pumps to provide cooling and heating for the girls. So we zoned face of each wing per level. So we have basically 4 indoor units coupled with 1 outdoor unit. Okay, so when we are talking about energy efficiency of HVAC system, certainly we need to differ energy efficiency of equipment versus energy efficiency of HVAC system. So in the context of heat pumps, in relation to improved technology of heat pumps, for example, with air-to-air heat pump, we can achieve COP as high as 4.5. While when we are talking about heat pump HVAC systems, it is so important that right control strategies, control parameters, control limits are implemented in order to maximize energy efficiency of a heat pump system. Goals are quite obvious and self-explanatory: maximize system energy efficiency, minimize the operating time, minimize load, minimize the operational maintenance cost, prolonged life of equipment. In terms of improving COP of heat pumps, we have a couple of options to deal with. To start with a better heat source and heat sink, or opportunity to recycle waste heat, or to do straightforward equipment improvements. Some of them Petrovich mentioned in his previous presentation. To optimize energy efficiency, it is so important that we have 3 parties on the same page, working together, starting from science, research and development, applications as consultants, and implementation that consider obviously good trades work and us involved with commissioning and ongoing fine-tuning of energy efficiency. So 3 heat pump projects very different to quickly review. First one is the one to show that even a heat pump with a great COP, ground source heat pump, in the context of inefficient HVAC system is also becoming inefficient as part of HVAC system. So first case is about regional visitor center in Alpine area in Australia. One level building, offices, visitor center and cinema. Government funded 24 ground source heat pumps, and that was advertised as a state-of-the-art HVAC system, which basically was. Problem was with implementation and a lot of problems. On picture you can see on the left side heat pump itself with a water inlet and outlet, simple controls, and ductwork running through roof void. This project is a typical example of design and commissioning deficiencies, which we identified through an energy audit, and surprisingly we identified the opportunity to save in excess of 50%, I mean to reduce energy consumption of HVAC system by order of 50%. Main deficiencies related to envelope of the building and controls. So in terms of envelope, I will show you next one. In terms of envelope, couple of things. Somebody by default put 15 square meters outside air louver as typically employed in buildings in Sydney, but in this snow region, that didn't do any favor to the building, as 30 centimeters very thick insulation at the roof was doing nothing, because through this hole of 15 square meters, temperature outside was nearly equal to the temperature in the roof void, negating purpose of the roof. Outside air was ducted with a common duct to all the units, so that wasn't needed. Why that was designed and implemented that way, that is a question for designer. Next one, got problem again. Anyhow, I'll just talk through. Next one was commissioning that wasn't completed properly, and some of return air paths were not ducted. So basically I explained to the client that the building was as building without the roof and with a couple of broken windows. So we fixed that and improved significantly situation with envelope of the building. And next great opportunity for energy efficiency improvement was about controls. So existing controls with just basically thermostats and time switches basically didn't include any of opportunity to use outside air for cooling, to optimize cooling, heating, deadband, space temperature, to minimize startup time during mild weather conditions, etc., etc. And I still can't move this screen. And by implementing a comprehensive building management system with advanced control strategies, control limits, control parameters, basically, and improving envelope in a way that we mentioned, we basically achieved savings of 47%, which was really great. Achieved actually through monitoring utility bills. So we're not talking about dedicated sub-meters, just utility bills basically identify this level of savings. Next case study, art gallery, small art gallery situated in a heritage house where painter used to live. So 24/7 requirements for regulated space temperature and relative humidity. And this is smaller object, so heat pump was suitable for that duty, around 50 kilowatts refrigeration. Now, that is a remote location in the mountain, and the issue was for reheating that normally is employed either by hot water coils or electric reheaters. that is remote location, we didn't have enough electricity, gas wasn't reticulated, so we faced either to upgrade electricity supply or to do something else. And we opted to add third coil and to basically recycle heat from condenser, and that really worked well. We also employed comprehensive BMS system to deal with the different modes of operation: cooling, heating, ventilation, humidification, dehumidification, reheating. Yeah, just in terms of challenges, limited electricity supply, no gas, harsh climate conditions. Noise was also an issue because it was mountain gallery, very low noise environment. Just engineering sketch showing operation of the system in reheating mode, where basically we just redirect refrigerant towards indoor condenser coil that basically is doing reheating after overcooling and extracting moisture to drop to reduce relative humidity. This is just print screen from BMS showing basically three-stage DX air-cooled heat pump and the way how controls operate. In addition, we introduced a couple of advanced control strategies, specific economy cycle, providing free cooling, free heating, running even in a deadband zone, demand ventilation, etc. So here is just a schematic of economy cycle that is running not only as a first stage of cooling, as typical use of economy cycle, but also for heating, and even running in that band zone, providing cooling. So importantly, we significantly improve indoor air quality by doing that and save energy. So as a sum of benefits, yeah, savings of more than 40%, reduced energy consumption, carbon footprint, eliminated needs for electricity upgrade, reduced noise, and also considering the heritage building, it was fairly important to minimize any damage, any modifications of the building. So we did modular installation of an indoor unit that was located in the roof void. So that helped us to avoid craneage, to avoid removing roof tiles. So very successful project. Third one, sewage treatment plant at one ski resort in Australia. Very unusual to have a sewage treatment plant at such height, 1750 meters, and because of that altitude, there is a need to heat sewage. And before we analyze the whole situation, basically for quite a few years, they use LPG bottle gas, very expensive. So typically during ski season, they spend more than 21,000 liters in 7 days. And over snow transport was also very expensive. So we came up with an idea to use a heat pump to supplement, to minimize that cost. Now question is how to use heat pump, generally speaking, at sub-zero temperatures, -10 would be a challenge. And then we found practical solution to recycle heat from effluent pond. So every 3 hours, we have processed sewage discharge into an effluent pond, and we measured during full ski season, the temperature didn't drop below 13 degrees. And basically, also one positive impact apart from reducing cost and improving energy efficiency of the whole system, we reduced thermal pollution of the creek into which effluent is discharged by approximately 5 degrees. And this project is being tendered, and projected outcomes are that we should reduce the energy cost by 62%, including over snow transport. So, simple conclusion, heat pumps can be successfully applied to a very diverse range of applications, including HVAC and industrial projects. high control expertise and ongoing involvement of energy management consultants is essential to achieve those outcomes. Because typically we have a situation where ongoing energy efficiency is not maintained really. We have sporadic energy audits from time to time. So with this kind of approach, energy efficiency can maintain on an ongoing level. Thank you very much.